So today's video is dedicated to prime factorization, and prime factorization will not be understood if you do not understand what factors are. So if you do not know what factors are, you need to go back and watch the video on factors. And just as a review, factors are the numbers that are multiplied together to get a product. So prime factorization is basically starting with a product or a number and then breaking that number down into all of its composite factors. So for example, let's start with the number 54. And we're going to make a factor tree, which enables us to get the prime factorization of a number. So as I indicated, let's start with 54. What you do with a tree is you sort of think of a Christmas tree, okay? So we're going to put 54 at the top like our Christmas tree topper. And we're going to split 54 into two numbers that can be multiplied to get 54. And it can be any two numbers, even if there's more than one pair of numbers that can equal 54. So let's just choose a very common pair of numbers that equals 54, as in, I don't know, let's say 6 and 9. So 6 times 9 is 54. And in our factor tree, the two numbers are multiplied always go right back up to the number that is its product. So 6 times 9 is 54. Now we look at each of the number on our branches of our tree and we ask ourselves, can these numbers be broken down further into factors? And actually both of these numbers can. So let's take a look at the 6. We're going to make branches for the 6. Okay? Now, what two numbers can be multiplied to get the product of 6 besides 1 and 6? And that would be 2 times 3 is 6. So 2 times 3 is 6. And remember, we're working with factors here. So do not confuse yourself with two numbers that can be added to get our number. It's two numbers that can be multiplied to get our number. So 2 times 3 is 6. 6 times 9 is 54. So it always leads back to our product that starts us off, or our main number. So we have our 2 and our 3 here. Now, if we try to split the 2, the only numbers that we have that can be divided between or multiplied to get to would be 1 and itself 2. So we're done, and we're also done with 3 because it also at this point is a dead branch. You can't divide out 2 or 3 any further. Okay? So I'm going to replace my 2 here. And this branch is complete. So let's go back to our 9. We're going to make branches for our 9. So what two numbers do we multiply to get to 9? Besides 1 times 9. And that would be 3. So 3 times 3 is 9. So again on this side, 3 times 3 is 9. 6 times 9 is 54. So both sides of the branches leads us back to our beginning number or our beginning product. And these end numbers that are on the ends, these are actually our factors of the number 54. At the very tips, considered prime factorization. Okay? So not only these factors of 54, such as 6 and 9, 2 and 3, but these are very special in the means that 54, okay, if you break down the prime factorization for 54, you would say it equals 2 times 3 times 3 times 3. So let's double check ourselves. We have 1, 2, and 1, 2, 3 of our 3. So 1, 2, 3. So this is what prime factorization looks like. And you should know that if you work your tree backwards, this is going to be 6 and 3 times 3 is 9, and 6 times 9 is 54. So we definitely know that our prime factorization is correct because it leads us to our final answer of 54. So 2 times 3 times 3 times 3 is the prime factorization of the number or product of 54. So go ahead and pause the video, because what I would like you to do is do the prime factorization for the number 36. Go ahead and do the prime factorization for the number 36. And after you've gotten the prime factorization for the number 36, creating your factor tree, unpause the video and see if your answer matches my answer. Go ahead and go. Okay, welcome back. I hope that you were able to use your factor tree in getting the prime factorization for 36, and hopefully you didn't have too much trouble. So let's take a look at 36. And as I said before, you can choose any two numbers that can be multiplied to get the answer 36. And there's a couple that we have to choose from. Some of you may have chosen 6 times 6 is 36. Others may have chosen 4 times 9 is 36. And still, some of you even chose that 18 times 2 is 36. So I'm going to go with the 4 and the 9. So I'm going to say 4 times 9 is 36. Okay? So 4 times 9 is 36. And 4 times 9 definitely does equal 36. So let's start with our first branch over here and splitting out our 4. So what two numbers could I multiply to get to 4? What two numbers can I multiply to get to 4? And that would be 2 times 2 equals 4. And as you remember earlier, 2 can't go any further because only 1 times 2 is 2. So there's no other numbers besides 2 itself and 1 that can be split. So we're done with these branches. So I'm going to go ahead and circle these branches to let me know these are dead branches. They are finished. And I'm going to come over here to my 9 branch and split that out. Okay. So what two numbers can be multiplied to get to 9? And as you remember from earlier, we said 3 times 3 are the two numbers multiplied to get 9. We also said that 3 could no longer be divided because only 1 times 3 is 3. So these are our unique factors, or for our prime factorization for the number 36. So we can say 36 equals 2 times 2 times 3 times 3. So how'd you do? Did you get 2 times 2 times 3 times 3? Because if you did, you just rocked that factor tree. Alright, well, just to review, prime factorization is when you take the product or what we generally call a number, okay, and we're going to break that number down using a factor tree, using two of its factors, and it can be any two factors. So for 36 we chose 4 times 9. You could have went with 6 times 6 or 2 times 18. You would have gotten the same answers in the end. And then once you come to the end of those branches, then you get your prime factorization. And remember that you're multiplying between each number, okay? So 36 is 2 times 2 times 3 times 3. And those numbers are all gotten from these numbers here, okay? So check back with me later, because now that we've gotten factors and prime factorization down, we're going to be doing greatest common factors next. So see you next time on Tutor with Angel.